Just a little longer?
Yoop, what are you doing?
I'm trying to reach the last bits of jelly, but my arm is too short.
Looks like your arm isn't long enough. We need to make it longer. Yoop's arm is too short to reach the jelly. Move the slider to make it longer.
You made my arm longer! Yummy!
Let's practice finding things that are short or long. Which vegetable is shorter? Indeed, the broccoli is shorter than the corn.
Which ribbon is longer? Good going! The green ribbon is longer than the blue ribbon.
Which thing is shorter than the red spoon? The fork is shorter than the red spoon. Long.
Short!
Which thing is longer than the mask? The wand is longer than the mask.
Tap all the things that are longer than the eraser. These things are all longer than the eraser.
Which thing is shorter than the fabric? The scissors are shorter than the fabric.
Tap all of the vegetables that are longer than the pepper. These vegetables are all longer than the pepper. Tap all of the vegetables that are
Which thing?
Tap all the things that are longer than the eraser.
Which?
Tap
Time for the quiz round.
Hold that thought, Flory. It's time for a scoring round!
Remember to work carefully.
Show what you know about things that are long and short. Which thing is longer? Which thing is shorter? Which thing is shorter than the battery? Which thing is longer? Which thing is shorter? Which thing is longer than the mustache?
Yoop, what are you doing?
I'm trying to make my tree grow tall so I can climb it. Right now, it's too short.
But you can fly. Why do you want a climbing tree? Yoop's tree is too short to climb. Slide the leaf to make it tall. Wow! Look how tall Yoop's tree is now.
Let's practice.
Yoop's tree is too short to climb. Slide the leaf to make it tall.
Let's practice.
Yoop's tree is too short to climb. Slide the leaf to make it tall. Wow! Look how tall Yoop's tree is now!
Let's practice finding things that are tall or short. Which ribbon is taller? Woohoo! This ribbon is taller.
Which vegetable is shorter? Good thinking. The pepper is shorter than the cucumber.
Which thing is taller than the potato? The popsicle stick is taller than the potato.
Tall.
Short. Tall. Which thing is shorter than the red spoon? The ribbon is shorter than the red spoon.
Tap all of the things that are shorter than the fork. These things are all shorter than the fork.
Which thing is taller than the wand? The paintbrush is taller than the wand.
Tap all of the things that are taller than the potato. These things are all taller than the potato. Tap all of the things that are taller than the potato. Tap all of the things that are taller than the potato. Tap all of the things that are taller than the potato. Time for the quiz round. Tap all of the things that are taller than the potato. Time for the quiz round. Tap all of the things that are taller than the potato. This is not the only thing that's taller than the potato. Look for more. Time for the quiz round.
Hold that thought, Flory. It's time for a scoring round!
Remember to work carefully.
Show what you know about things that are tall and short. Which thing is shorter? Which thing is taller? Which thing is taller than the screw? Which thing is shorter? Which thing is taller? Which thing is taller than the scissors?
Hi again. Are you ready to practice some more math skills?
We'll unlock different doors on our quest to the quiz.
Let's go! There are a lot of numbers that add together to make 10. Now let's practice finding numbers that add to 10. Ooh, look!
Use this to unlock the door.
Help us sort some tiles. What is 4 plus 1? What is 2 plus 4? What is 3 plus 4? What is 3 plus 3? What is 3 plus 2? What is 5 plus 2? Awesome! All the tiles are sorted.
What is 4 plus 4? What is 5 plus 5? What is 4 plus 5? What is 6 plus 4? What is 5 plus 3? What is 7 plus 3? Excellent! All the tiles are sorted.
Which shows a way to make 10? Awesome! 5 plus 5 equals 10.
Which shows a way to make 10? Well done! 8 plus 2 equals 10.
Choose all the cards that show a way to make 10. Double wow! 1 plus 9, 4 plus 6, and 8 plus 2 are all different ways to make 10. Choose all the cards that show a way to make 10. You haven't found all the cards that show a way to make 10. Try again. Time to play Build That Number! Find number partners for 10. Tap pairs of cards that make 10 altogether. Each pair makes 10.
Find more number partners for 10. Each pair makes 10.
Five plus what number equals 10? Find the missing number. Woohoo! 5 plus 5 equals 10.
Four plus what number equals 10? Indeed, 4 plus 6 equals 10.
Two plus what number equals 10? Awesome! 2 plus 8 equals 10.
Seven plus what number equals 10? I knew you could do it. 7 plus 3 equals 10. Your quest is almost complete.
Use the star to unlock the quiz.
Show what you know about adding to 10. Try your best. Which shows a way to make 10? Which shows a way to make 10? Which shows a way to make 10? Choose all the cards that show a way to make 10. Six plus what number equals 10? Find the missing number. Three plus what number equals 10? You can break apart numbers by place value to multiply them. First, multiply the parts. Then, add the partial products.
Which three cards have equal values? How do you break apart the factor 627 using place value? 627 is equal to 600 plus 20 plus 7. What's this partial product? What's this partial product? What's this partial product? What is 3 times 627? You got it! The total product is 1,881, which is the area of the whole rectangle. What's this partial product? What's this partial product? What's this partial product? What's this partial product? What's the sum of the partial products? What is 5 times 8,172? Nice! The total product is 40,860, which is the area of the whole rectangle. Find all the expressions that can be used to solve 7 times 53. These expressions can be used. Find all the expressions that can be used to solve 2 times 385. These expressions can be used. Find all the expressions that can be used to solve 4 times 6,041. These expressions can be used. Find all the expressions that can be used to solve 4 times 6,041. Almost. There's another expression that can be used that you didn't select. Try again.
What is this partial product? What is this partial product? What is 8 times 47? What is this partial product? What is this partial product? What is this partial product? What is 6 times 457? What is this partial product? 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 What is the sum of the partial products?
You can use place value to help compare numbers. Start with the greatest place. Compare the digits. If they're the same, look at the next greatest place, and then compare those digits. Let's look at some more numbers. Now let's use place value to compare larger numbers. Complete the statement. Choose the symbol that makes the statement true. Complete the statement. Choose all the numbers that are less than 6,093. Select less than or greater than to complete the comparison for each pair of numbers. Choose all the numbers that are greater than 15,389. Select less than or greater than to complete the comparison for each pair of numbers. Choose all the numbers that are greater than 15,389. You haven't found all the numbers that are greater than 15,389. Look for more.
Complete the statement. Choose the symbol that makes the statement true. Complete the statement. Complete the statement. Complete the statement. Which number is greater than 52,136? Which number is less than 174,021? You can use a protractor to find the measure of an angle. This angle is 62 degrees.
Find the measure of this angle in the square. Move the center point of the protractor to the vertex. Rotate the protractor to line up one ray with the 0-degree mark. Each angle in a square measures 90 degrees. Choose all the angles with a measure of 90 degrees. Choose all the angles with a measure less than 90 degrees. Choose all the angles with a measure greater than 90 degrees. Look for other angles that are greater than 90 degrees. Look at the angle. Which description is true? Let's use a protractor to find its exact measure. Find the measure of the angle. Move the center point of the protractor to the vertex. Rotate the protractor to line up one ray with the 0-degree mark. You can tap here to get a closer look. Look at the angle. Which description is true? Let's find its exact measure. Find the measure of the angle. Find the measure of this angle in the triangle. Find the measure of this angle in the triangle. Find the measure of this angle in the pentagon. Find the measure of this angle in the rhombus. Find the measure of this angle in the rhombus.
Look at the angle. Which description is true? Find the measure of the angle. Look at the angle. Which description is true? Find the measure of the angle. Find the measure of the angle. Find the measure of this angle in the triangle.
Victor's Mind Meter Challenge goes live tonight, and I can't get past the first question. Maybe Victor has finally outsmarted his maker.
Well, bro, good thing your older and wiser sister is always one step ahead of you. We need to know how to add and subtract 2 and 3-digit numbers to complete Victor's challenge. This Cube IQ app should come in handy.
So, we can use flats, rods, and small cubes to model numbers? Genius!
I know I am. Find the sum. 165 plus 123. We can build each of these numbers with base 10 blocks.
Cue the app.
Let's start with 165. I can drag 1 flat to represent the 1 in the hundreds place.
And I'll drag 6 rods to represent the 6 in the tens place.
Finish building the number by dragging small cubes to show the ones. Check you out! 165 can be pictured with 1 flat, 6 rods, and 5 small cubes, and can be written as 100 plus 60 plus 5. Now it's your turn to drag blocks to build 123. You got it! 123 can be pictured with 1 flat, 2 rods, and 3 small cubes, and can be written as 100 plus 20 plus 3.
Now, let's combine all of the blocks. How many flats, rods, and small cubes are there in all? Now, let's combine all of the blocks. How many flats, rods, and small cubes are there in all? Roger that. If we combine the blocks we get, 2 flats, 8 rods, and 8 small cubes, that's 200 plus 80 plus 8.
Find the sum.
You can use the blocks or the expanded form to help. Precisely. Using the blocks to help break down each number into its expanded form makes finding the sum a snap. Level 2. Looks like we need to break apart numbers and find their sum. Let's try.
Find the sum. 312 plus 177. Write 312 in expanded form. That's not it. Think about how to build the number using base 10 blocks and try again.
Level 2. Looks like we need to break apart numbers and find their sum. Let's try.
Find the sum. 312 plus 177. Write 312 in expanded form. That's not it. Think about how to build the number using base 10 blocks and try again. You got it! Now, write 177 in expanded form. You got it! Now we have both numbers in expanded form.
Add the hundreds, tens, and ones. That's affirmative.
Voila! We should be able to find the sum now. Find the sum. Nice!
Level 3. Looks like we can use a number line to add 2.
Let's try it. We can use the number line to add by counting on.
Let's write 114 in expanded form so that we can count on in parts. What is 114 in expanded form? That's affirmative.
Now that we have 114 written in expanded form, we can add it in simpler parts. To add 100, we can start at 246 and jump forward 100 on the number line. Click on the Add button to show jumping forward 100. Where do we land after we add 100? You got it!
Now let's jump again to add 10 to 346. Click on the Add button to show another jump. Where do we land after we add 10? Roger that.
Now let's jump forward to add 4 to 356. Click on the Add button to show the last jump. Where do we land after we add 4? Check you out! So, 246 plus 114 equals 360.
I wonder if a number line will work for subtraction too. Let's try. Find the difference. What is 80 minus 32?
We can think about this subtraction problem as finding the number we have to add to 32 to get 80. If we can get to the next 10 on the number line, the next jump will be simple. We're at 32, so the next 10 is 40.
What do we need to add to 32 to get to 40?
Check you out! We've made it up to 40, and we need to get to 80.
What do we need to add to 40 to get to 80? Roger that. But how does this help us find the difference?
If we add up all of the jumps we made on the number line, we'll know what to add to 32 to get to 80. What is the sum of all the jumps? You got it! We jumped 48 to get from 32 to 80, so 80 minus 32 is 48. Let's try another one.
Find the difference. Oh, snap. This looks trickier.
Not trickier, just greater numbers. I can use the number line again and just count on from 157 until I get to 302. I'll make the first jump. If we start at 157 and add 3, we will land on the next 10, 160. Let's jump from 160 to the next 100. What do we need to add to 160 to get to the next 100? Check you out. I'll make the next jump. To get from 200 to 300, I'll jump forward 100. What do we need to add to 300 to get to 302? You got it!
Now we can add up all of the jumps that we made to get to 302.
What number do you need to add to 157 to get to 302? Check you out!
And this means that 302 minus 157 equals 145. Ready to read Victor's mind?
Bella added 475 plus 32 and got a sum of 405. I think there is a problem with her addition.
Try the two sentences that match Victor's thinking. This is a great explanation for why Bella's answer is wrong. I'm not too sure about this one. Try again. Roger that. These two are great arguments for why Bella's answer is wrong. This one doesn't make sense. The 4 in the first number represents 4 hundredths. The 3 in the second number represents 3 tens, not 3 hundredths.
Bo used a number line app to solve 470 minus 360. Bo's number line jumps are plus 40, plus 100, and plus 70. I think there is a problem with his number line.
Drag the two sentences that match Victor's thinking. This one works, but I'm not sure that 40 plus 100 plus 70 actually totals 360. Try again. Nice! Both of these choices explain that these jumps take you past 470. The landing spot after jumping 40 is 400. I think the plus 100 jump might be the bug in Bo's program.
Hey!
Beta testing complete.
And now we're ready to go live!
Felix solves 346 plus 271. His answer should be closest to the blocks show 287 plus 322. What is this sum? Find the sum. Which of the following shows a way to add 417 plus 352? Find the difference. Rihanna used this number line to solve a problem. Which problem could she have been solving? What is 415 minus 180? Maddie solves 205 minus 150. Her answer should be closest to
Wow. Sorry, boss. This place is a mess.
Yeah, man. Maybe we should clean up a bit.
Let's start with these jars of sprinkles. I could put them on some empty shelves.
That's a lot of sprinkles, sweet tea. I don't think they'll fit on one shelf.
You're right, but we have these 3 shelves we can use. Put the same number of jars on each of the 3 shelves. Sweet! Each shelf has the same number of jars. This arrangement is called an array. An array is an arrangement of things in rows with the same number of things in each row.
We see rows in lots of different places. How many rows are in this array? Bake on. Each shelf is a row, and there are 3 shelves.
How many jars are on each shelf? Yep. Each shelf has the same number of jars. There are 4 jars on each shelf. Now we can add up the number of jars on each shelf to see how many jars we have in all. Write an equation to find the total number of jars. Look, I've started the equation for you. 4 plus Yep. Each shelf has 4 jars. There are 3 shelves. So adding 4 plus 4 plus 4 will find the total number of jars. Now we can add up the number of jars on each shelf to see how many jars we have in all. Write an equation to find the total number of jars. Look, I've started the equation for you. 4 plus You sure about that? Each shelf has 4 jars. There are 3 shelves. So adding 4 plus 4 plus 4 will find the total number of jars.
How many jars do we have in all? Rock on! There are 4 plus 4, which equals 8, plus 4 more. That's 12 jars in all. All right, sweetie. The sprinkles have been sorted. What's up next?
This mountain of cake boxes is out of control, boss. Let's get to stacking. Drag the boxes to the stacks so there is an equal number in each stack. You sure about that? Keep going. Move the boxes around so each stack has the same number of boxes. Yep. Each stack has 5 boxes. We just made another array. There are We just made another array. There are 3 boxes in each row, but I also see an equal number of boxes in each stack. Each stack of boxes in this array is called a column.
I can think of lots of places I've seen columns. How many columns are in this array?
Yep. Which equation shows how we could find the total number of boxes? Sweet! Each stack has 5 boxes, so 5 plus 5 plus 5 will give us the total.
How many boxes did we stack in all? Bake on! There are 5 boxes in each stack. We could skip count by 5s to find the total. 5, 10, 15.
Okay, I know we are supposed to be cleaning, but I can't help but see arrays everywhere. Check out these quail eggs.
Those are some quirky quail eggs, sweetie. I see an array with 5 columns. 4 eggs in each column.
No way, dude. It's an array with 4 rows, 5 eggs in each row. Click on Jake to find out how he finds the total number of eggs in the carton.
I see 5 columns of eggs. How many eggs are there in each column? Rock on! There are 4 eggs in each column. Now I can add up the number of eggs in each column to find out how many eggs there are in all. How many eggs are there in all? That's it.
I think I see how you got the total, Jake, but I see it a different way.
Click on Sweet Tea to find out how he finds the total number of eggs in the carton.
I am all about the rows, boss. Here, I see 4 rows of eggs. How many eggs are there in each row? Yep, there are 5 eggs in each row. Now, I can add up the number of eggs in each row to find out how many eggs there are in all. How many eggs are there in all? Yep. Each row has 5 eggs. We can skip count to find the total. 5, 10, 15, 20.
So, it doesn't matter how you look at the array. 5 columns of 4 eggs gives us 20 eggs in all. And so does 4 rows of 5 eggs.
That's extraordinary. Hey, boss. I got a little excited about organizing these boxes. A little help? Boss?
Which sum describes the total number of stars in this array? Which sum describes the total number of apples in this array? Dion collects stamps. He arranges his stamps in an array like this. Write an equation that describes this array. Write an equation that describes this array. Which of these pictures shows an array that has 5 rows with 3 ice cream cones in each row? These soccer balls make one row of an array. Anna lines up chairs in 2 rows. She puts 4 chairs in each row. The windows on a building